Good morning, good afternoon, good evening, everyone. Welcome on the Learn Grasshopper workshop. We are continuing our Tekla workshop. It's our 11th workshop, so I'm really happy that we continuing this series. And today we have special guests, two guys, one from Sweden, one from Finland. That are working on this amazing Tekla Live Link. We have the father of Tekla Live Link, Sebastian Lindholm. Hello, Sebastian.
Hello, Chris. Nice to be here again.
And Simon, if Sebastian is father, so you will be going to be his son, or?
Yeah, I think that's a good good view on it. And yeah, thanks for having us.
So for those who are first seeing Simon, so Simon has been working with Sebastian lately as a part-time of his job. So you are working for Trimble, Simon, right?
Yes.
But you're not working 100% on Tekla Live Link. What you are up to in Trimble?
Now I work as a software manager and handling things and regarding Tekla structures and what's in the pipeline and those kind of things. And as you mentioned, like I work with this partially for the last year, more or less. And now we come up with this Welds and Rebar set that we're going to show, amongst other things.
Yeah. So you are main person responsible for Rebar sets and welds? Or you've been working together with Sebastian on that?
Both, but I guess just for this, I think I've done a little bit more than him, but feel free to blame us both.
So yeah, all the credit for you and blame Sebastian because he's answering on that.
I was hoping the other way around now, but I guess it's still me on the forums mostly.
Yeah.
And Sebastian, you are 100% on Grasshopper Tekla Live Link on the development, answering all the questions on the forum.
Yeah, more or less.
Perfect. And today we are going to show what's new. So first, Sebastian is going to share his work and what's new. Which version we are actually right now is official version Live Link?
1.19 is the official one. So we will have some stuff from the latest, but also from the previous two versions, I think, which were released now during the winter. So the Rebar sets, for example, I think we released them already in the autumn, but now for 2025, they have been enhanced with more guidelines and stuff. So they are even more usable than before.
Yeah. Ibrahim asked, does it have polygon cut, the new Live Link?
It does not, but that's a good request. I mean, essentially, just to quickly answer that one, a polygon cut in Tekla is created like under the hood by inserting a plate with a boundary and a thickness and creating a Boolean cut. But in the user interface, you just pick your polygon. So you can already kind of do that yourself with a part cut in Grasshopper. But of course, there's some automated logic there that would be nice to have.
Okay, but do you plan this polygon cut, or do you think this workaround with cutting with the plates and like a Boolean is more than enough?
Yeah, it is on the list, but the list is quite extensive by now. So
yeah, and maybe it's not the first thing to do when it comes to like if you have a workaround. So maybe focus on something that is missing.
Yeah,
I already got question on my email. What about bolts?
Yeah, that's another good one. We tried, or actually a reseller tried to do something about bolts a while ago, and they have a demo working, but I'm not sure when or how they are going to release it. I'm hoping that once they release it, we can integrate it to the like official link as well. But me and Simon haven't done anything about bolts yet.
Okay. So we can just patiently wait for what's coming. There's few people already. Hello Arturas, hello Ibrahim, hello Volde. Nice to see you here. It's already 2 p.m. Central European time, so let's start. Let's go to presentation. We will start as always. We are on the free platforms. We are on the Facebook, LinkedIn, and YouTube. And please if you can leave a like or subscribe. Hello everyone, DJ is with us. Great to see you. So session, we will not have it more like 1.5 hours, let's say 90 minutes, but it depends about your questions. Recording will be available as always together with the Grasshopper script. Simon and Sebastian is going to share with us the all Grasshopper script that are going to show. So learngrasshopper.com/Tekla2025 or scan this QR code. And as always, if you have any comments, requests, so now is the best time to ask developers themselves. Maybe you can push a little bit. Maybe we can count the number of requests. So the most common your request, maybe we can push Sebastian and Simon to put them a little bit higher on the list. So be active on the chat. So you have Jan, Ivan, nice to see you, Volde. Great. Nice to see you again, Simon. I attended your presentation at the Tekla User Day in Sweden. What was presentation about, Simon?
It's kind of the same, so it's going to be some repetition, but kind of the same, but for another audience.
Nice. Maybe Volde, maybe you have now room for questions, so maybe Simon can, or maybe you have some another things to answer or comment, so please write that. People already asking about groups, so we are having that on the list. Hello, David. David is with us. If I remember correctly, David from New Zealand. So yeah, it's really late. So great to see you here. So Sebastian and Simon going to show us what's new in new Tekla Live Link, what have been added, and what's new into Tekla 2025. And as I said, you are going to get all scripts that guys are going to show. For those who are seeing me for the first time, my name is Chris. I'm an online educator. I've been conducting Tekla Grasshopper workshops. We have 6 workshops in 2024, and we are continuing this series. We have first one in March with Oscar about prefabrication. This workshop is still available to watch and download the materials. Later, we had with Joel about how to automate reinforcement drawings. Great session, lots of practical examples. Next, Sebastian, that you can see right here with me. He been attended also the bridge session where we talk about the total workflow, how to create bridges in Tekla through 3D modeling, and then Greg Olszewski, creator of a Grasshopper Tekla drawing link, showed his presentation. He just shared the good news today that his application to Dimensions been accepted. So good that Tekla, like Trimble, is seeing the potential of Grasshopper Tekla drawing link. And we have also Gabriel Neves that he showed also talk to us the good routines for the drawing creation. And last week we have Nathan Luke from Idea Statica, and we showed great workflow, kind of new way how we can collaborate and send data between Tekla, Idea, and to Karamba, like free softwares without any additional files, just through Grasshopper. So Grasshopper is our centralized model and great workflow to send information back and forth and connect components with Idea Statica components. So for those who would like to know more about Grasshopper, I really recommend go to my website, learngrasshopper.com. I'm trying to teach engineers and transform the engineering work into fun with the use of programming. Last year, we together with Greg, we have created comprehensive Grasshopper in Tekla training. We had more than 200 Tekla super users, where from scratch we are teaching how to use Grasshopper, how to automate all the boring stuff in Tekla, and how to build your own tools. So just information, the recruitment for the second edition starts next week. So next week we are opening. You can save your spot already on grasshopperintekla.com, and we are going to try to limit the number of students to 200 as it was previously, because we think it's the optimal number of students to take care for everyone. Okay, so that's all from the introduction. Let's go to what's new stuff. So I'm going to share Sebastian screen. And Sebastian, what have been you working on lately, and what's new in the Grasshopper Tekla Live Link?
Yeah, thanks, Chris. So we're gonna go over a bit what's new. Like I said, it's from like the last year or so development, but focusing on the latest additions. And I said the most important two pieces are the rebar sets and welds, which Simon has been authoring. So he will go through them then in the later half of the webinar. But no, first we're going to look at some of the like smaller additions and updates that we have to the live link, starting with the installation process and how to load the link. So if we open the warehouse page for the Grasshopper link, we can download the latest package. And then we can open the zip file. And in here you can see that we have a bunch of files, and the setup is the one that we want to trigger first, because that will ask us to extract this package, which we can do. And then inside that package, when it's extracted, we launch the setup again. And at this point, it tries to install the link. You might get some warnings like I get here about, not being safe, or maybe some admin rights required and so on. If you just allow all that, it will then place a copy of the link into the libraries folder of Grasshopper, so where your plugins normally go for Grasshopper. So you can see that it has copied two files, the loader and the 2025 DLL file, into the libraries folder. And this process you can actually do for all the link versions. So if you want to install 2024, you do exactly the same, run the setup. It will then copy also the 2024 version here and so on. So the new thing is that you can have multiple versions installed in parallel. And then once you launch Grasshopper, it will automatically detect whatever Tekla version you're currently running and load the appropriate link version. And in case you have more than one Tekla version running, it might show you a pop-up with a version selector, like which Grasshopper link do you want to use.
And
but the loader,
I need going to use the latest version. What if I'm going to install the newest version? So it's just replacing the old one. If I'm going to, let's say, install from 18 to 19 of Tekla 2025, what's happening?
Yeah, so the setup here, if you run it, it will always replace whatever is already here. So if I take a newer package, it will replace the DLL file and put an updated copy of the loader into the libraries folder. But the loader can also...
I really appreciate this change, because many students ask about that, because it's really common in companies that are working with Tekla that they have 5 Tekla version installed, and just switching before it was nightmare, but now it's really, really easy, and I love how it's working.
Yeah, that's good to hear. That's what we tried to address. Another thing we tried to address was also loading the drawing link at the same time. So now the loader actually, if you have the drawing link installed, the latest version, it will also load that one. So it will actually load anything starting with Grasshopper Tekla that is a DLL. It will try to load as a Grasshopper plugin. And it will try to sort out the version also based on the file name here for the drawing link. So that means you don't need to put any files into the Tekla bin folder anymore, and you don't need to copy any Tekla DLLs like from the API into the Grasshopper folder. It should just work like out of the box. And that also means that you don't need to run anything as an administrator, like copying files to the bin folder, for example. If you are prevented from running the setup.exe because of admin rights, you can just manually copy these files also to the libraries folder. Then you just need to remember to unblock the loader file, like you normally need to do with Grasshopper plugins. You would have an unblock button here. But the rest of the files will get unblocked automatically then once Grasshopper launches. And if you do the setup, you don't need to unblock anything. Then it just should work.
Yeah, so the old method is still available.
Yeah, exactly.
And there was one question from Ibrahim: is the Tekla drawing link 2025 available? Yes, the Tekla 2025 is available on the GitHub, and you can install it with the same methodology that Sebastian is showing. And the good news that we are going to share that in June it will be Tekla drawing link will be available on the warehouse.
Okay, that's good to know as well. And a comment to that one is that even if you have an old, which I do here 2024, because the loader will connect with 2025, it will also bring in the 2024 link into 2025. So you can use that in 2025. Of course, if there are new features in 25 that you want to access through the new version, then take that one. But already now I have the drawing link here and I can use it in 25, even though it's the old version. Just as an added bonus. Right, then we have a new way of referencing objects from Tekla that solves an issue. So normally, you would set multiple objects in a Tekla parameter by just, let's see if I can activate the command, selecting the objects in Tekla, and it brings them in. But that doesn't work for bolts, as some of you have noticed. So if I try to area select the bolts, nothing really happens. So instead, what I can do now is to area select them already in Tekla and then activate the command, like you can do from Rhino objects as well. And that will bring in all the bolts as a group. The same this is an API limitation, and the same limitation is true for, I think, reference model objects, for example.
That's a great improvement, and also in this method, Grasshopper and Rhino will not be minimalized, right?
Yeah, exactly. So it just flashes by. And there's some filtering built in. So if I instead use the beam parameter, for example, it will only read in the beams that I've selected and filter out the rest. And here the columns
nice.
are considered beams as well, because they are beam type objects. But it didn't take the bolts, for example.
So in model object will land everything which I'm selecting. If I'm selecting reference or bolt arrays or booleans, so everything will be in the bolt, but in the beams only beams and columns,
exactly,
of course, because
exactly like that. Yeah.
Cool.
Right. And then we did an update to the get property component. So if I want to read a property from an object, doesn't matter if it's a report property or a user-defined attribute, I can just use this same get property component. So here I'm reading the GUIs from those bolts, getting them as a list. In some cases, you might have the same name of a UDA that you have of a report property, and you don't know which one to choose, or the component doesn't know. So then you can go here and change to the report and user-defined property. But normally you can leave it at auto, and you don't need to know what type of property you're reading. It should just get them here. And to help with knowing what properties to use, we have this new property catalog component. And here you can search through all the report properties and UDAs that are defined in various settings files. So for example, if I want something to do with length, if I can spell, of the bolts, I can search for properties, and maybe these are the ones I'm interested in. I can check their names and also just set them here in a component and use instead of manually typed names to get those properties.
I remember that I had to search through the list. I do not remember the name of the list, but it was like a text file with the maybe 200, 300 property names. But now it's really cool to have this filter and look for, because even if you search for the length, we can find like 20 types of the length in the property.
Yeah, and it's hard to know which one is which one. Here you could, in theory, just select 1,000 properties and see which values you get. Most of them will be null, but then you can maybe identify which property you actually want.
Because you can select more than one from the property component?
Exactly, yeah. So everything I select here
okay.
will get then for bolts, this will all be null because these have to do with reference objects, I
Okay,
think.
that's good to know. It's just holding with shift?
Yeah.
And it's stored in the data tree, or how is it stored? How is it working?
It's stored in a list, so the output here will be the list of selected names as text.
And the output, it will be data tree that for every single branch will be for particular property.
Right, yeah. So then the output here is one branch per property, yeah, correct. So going back to the GUIDs maybe. I was going to show this component, which it's not perhaps that new, but it's really useful. So it can take a list of GUIDs and then return whatever objects those GUIDs belong to, like the bolts in this case. And this list doesn't need to be a panel. It can, of course, be brought in a text file or from an Excel sheet. Or then you can use it together with the data output and input components or with Speckle, like to transfer information about selected Tekla objects. Because if you try to transfer these objects directly through some means, they are tricky to serialize. Most of the time it won't work. But this way you can share information about certain objects and then retrieve the actual objects in the model with the object by GUID component.
What about grid? Can we also refer that? We have Sergey who is asking about that.
Yeah, so in the sense that I can pick the grid from here, and that. All right, it doesn't have a GUID. That's probably why you asked. Okay, I sometimes encounter this one. I don't remember now if there's a workaround for this one that you can't read the GUID of a grid. That's something I need to check up.
Because if you're taking like with the expand object, what is coming
from the grid, you mean?
From the grid, yeah. Maybe it's just it's not having any. Let me see.
There is an identifier.
Yeah, maybe this will be something.
Okay, so that's one way to get the GUID. I don't know what it doesn't work as a report property. That's curious. But this way, yeah, you can at least retrieve the GUID of a grid.
Yeah, that's good workaround.
Yeah. And finally, the set phase component, which I feature here as well. With this one, you can set the phase of any model object directly. There are inputs, of course, on the individual, like create beam component and so on. You can have part attributes, but here you can grab any model object and just set the phase directly. So setting the bolts, for example, into phase 2 and naming it bolts will, in the phase manager, create a new phase called bolts and put the objects there. And it keeps generating then phases on the fly. So if I increase this number, you see I get more phases here. And you can then, of course, remove the old ones if you want to. And then we also have a component called the phase catalog, which will access the phase manager. And from this one, you can also select whatever phases are already available in the model. And instead of inserting the numbers manually here, we can just set the phase using the catalog, which is another way to set the phase.
And while you've been changing the number with slider, so this Tekla objects with this bolt arrays, they're going to be in the last one when you're going to change?
Yeah, they will be moved every time I change the slider value. And the rest of the groups would be then empty. So it doesn't remove them because, well, maybe it should remove them, but we'll look at that in the next update.
Yeah, because it has to be empty if you have to delete that.
Yeah. So if they're existing, you couldn't remove them, but we'll take a look at it. Next, about the plugin inputs. So you probably all know that it can be tricky sometimes to figure out what's the correct input sequence for certain plugins in Tekla structures. So just to refresh everybody's mind, there's a distinction between like details and connections, like the ones that are identified by this green cone. They have really well-defined inputs, like a detail is a main part and a position, for example. But then when it comes to plugins, which are identified by these macro symbols, they can have kind of arbitrary input. They can be, a group of objects followed by a group of points, followed by a curve, by another point, and so on. And there's no way in the API to actually extract like what's the input sequence I really need for this object. So as an example, let's take the floor layout component, which in the Tekla user interface, it just asks me to pick 3 or more points, and then it will insert the floor layout component. So that seems straightforward enough. If I now try to do that same through Grasshopper, it will ask me for plugin input, and I connect the plugin input component. And then I figure out, hey, I just picked a polyline here in Tekla, so maybe I just need a polyline here in Grasshopper. But no, that does not work. Because internally, this component needs a different set of inputs than what you are asked to pick in the user interface. And that's the actual input we need to provide through Grasshopper. So to help figuring out what kind of input we want, there's a new button here, Setup Inputs, which when you activate it, you are asked to pick one component in Tekla that you have manually inserted. It will read the inputs that were used when you created that component, and give them to you here as explicit inputs for this component.
Nice. So it's in kind of way cloning all the inputs.
Yeah.
But you have to create that manually first.
Yeah, exactly. So first you create one manually, then you set up inputs to read the inputs from that one.
Mm-hmm.
But this still maybe it's not that clear. We have the polygon, sure, but what are all these other points? So here we can try to figure them out, for example, by referencing in, again, a manually inserted component into Grasshopper. And then we use this deconstruct component. And here we can check like the input types. These are the same that we got here, so that's fine. And then what the actual inputs were. And we can see that there are points, then the polygon points and another point. Still maybe not clear. We can then take a look at what are these actual points. So by exploding this tree and looking at them one by one, we see that in Tekla, we have that point in the first corner. That's probably our starting point. We get a second point over here and a third point. Okay, so now this maybe starts to look like axes of a coordinate system. And the fourth input would be then, that's our polygon. Yeah, that's clear. And then the fifth, so that's something in the Z direction. So hopefully you can start conclude that these extra points, they define some kind of coordinate system that gets inferred automatically when you do it manually in Tekla. But here we need to provide those extra 4 points explicitly. And once you have figured it out, you can try. I have here added some pre-picked point in Tekla just to show that when you have all those inputs correctly, then it will actually create something in Tekla.
Yeah, this is from Greg. Brilliant improvement with the plugin input. I really like it because before it was, it's still a little bit detective work.
Yeah,
so you have to figure out. It's not that easy, but like as you said, these components with macros, they are defined in really different ways. So yeah, you have to do it anyways. So that's much more easier, and especially that like the order here is set up already. So this is a good news.
Yeah, I hope so. Next piece, multisection profile. So this is a component that will create. It's still a fixed profile, so it won't be parametric or variable, but it can have more than one cross section that it then lofts between. So in this case, let's say that I have these pipes here going from a square to a round one, and I want to have some kind of beam pipe profile that lofts between them. So I can try to do it here using a rectangle as one of those shapes, just a normal rectangle. And then at the end, the final section should be a circle like this. So in theory, I would just need 2 sections, but here I decided to put in a couple more just to make it smoother, the transition. And then I can just feed, these are like a group of outlines. I can feed that whole group into the multi-section profile. And then to make it hollow, I feed another group which are slightly smaller than the first set of sections. And together they have now inserted a new profile into Tekla structures, which I have named Squircle here. So to try it out, because now it exists in Tekla, I can first try to do with Grasshopper, do a beam here. So picking 2 points and enabling this one, we'll insert a beam that uses this new profile. But this profile, it now exists in the Tekla profile catalog. So I could turn off Grasshopper and close everything down, and this is now part of the Tekla model itself, which also means that I can use it manually in Tekla. So activating the beam command with that profile means that I can insert it in several places then by just pointing and clicking.
And this is the biggest difference between the item, like we've been doing this kind of profiles for now, and here, because you can change the beginning and the end, and maybe it also takes less memory if we are going to define that
they
with,
are far. That's a very good point. They are far more effective than items in terms of the amount of storage they take in the model, and also how quick they are to work with through the Grasshopper link. So the profile generation itself, that takes some time, but once it's in the model, I could create 10,000 beams and it wouldn't be any different from creating 10,000 normal beams. And 10,000 items would just take a lot of time. Here, let's see just what happens, because this is a fixed profile. It doesn't have any parameters in Tekla, but of course I can update the profile itself through Grasshopper. And if I do that with the slider, you can see that it updates the profile of all the beams that I inserted, also the ones I inserted manually, which might or might not be what you want to do. So if I want to instead just keep these profiles in Tekla, like the old ones, and perhaps create a new one which has a different diameter, the easiest way would be just to go here and give it a new name. And then the old one will forever remain in the Tekla profile catalog. But now I have a second one, which is named Squircle 2. And the only one of these that uses it is the one I inserted through Grasshopper. So that one will change when I update the dimension, but the rest are now left as they originally were. So a few more things. Plate chamfers. So for this one, I'm going to just generate some plates. And if I want to now chamfer one of the corners, I have this new component called chamfer corner, which takes the part as an input. Then the index of the corner I want to put a chamfer on, let's say 1. And then with this chamfer component, I can specify what kind of chamfer I want and insert that chamfer at the corner with some parameters. And I can change the corner to chamfer. And I can also insert more than one chamfer, like if I want some at the second corner, or 0 and 1, for example. I can change the type of the second chamfer as well. So it just works like you would expect, hopefully. The one thing I want
to... But it also can be used with beams, right? With the poly beams.
Yeah, correct. So if I had beams here instead, those will also get chamfered. The point order for the beams is a bit different here, and I'll get to that actually now. Because it's good to keep in mind here that the point will be the order of points that actually come out of Tekla. So once the profile has been, or the plate has been inserted, that is the point order that then we need to use here. So looking just at the boundary of the plate that we just inserted, we see 0, 1, 2, and 3. Okay, that's fine. We see it goes counterclockwise. But then on the other hand, if we look at the input curves and the point order there, this is really small, but they actually go clockwise, so the other direction, 0, 1, 2, 3. And that's because in this case, the plate component, it will orient them automatically to make sure that the up direction of the plate is always in the global Z direction, so that positioning and stuff works as intended. So there might be something that changes the point order which is why we can't rely on the point order of the input. We need to use the point order of the output. And to make this even more clear, let's see what happens if we instead select this arc profile or boundary for the plate. We can see we still have only 4 points defined, but if I use that for our plates, let me remove that one. You can see that now it gets really messy because Tekla inserted all these extra points because it needs to break up that curve into multiple small segments. And now the point order is something completely different from what I expected. And to target these corners, I would need to use 47 and 48, for example. So this is just something to keep in mind when you work with the chamfer component.
Before it was like a workaround, it was with the C# JAS script. So now you can freely use this chamfer for both polybeams and plates.
Yeah, exactly.
Perfect.
2 more to go. Attach to part, this is a simple, straightforward component. So if I just generate some columns here and then some corbels, and we want to give a small angle underneath, so why not use the new chamfer component? And then for good measure, we can put some load on top of them. And now in many cases, I would like to attach this part to the main part, and there's a component for it where we select the input column and then the part to attach. And that will now merge these 2 objects into one. So you can see the outline here of both objects. And if I inquire them, I see the combined volume and weight of them and so on.
But do they have to have the same material while connecting?
That's probably true, yeah. Actually, I can probably test that. So if I put something else here.
Because on the poor object is maybe like that. I'm not sure with the attached part.
Yeah, failed. It might be because of that.
Yeah.
No. It did. Maybe it just changed the material of both now. No, that's still, it actually managed. So that's C40 and this is undefined. So apparently it's possible.
Yeah, I think it's just for poor objects that they have to be the same concrete.
Yeah.
Yeah.
And final small addition here, a grid plane component. So let's say we have some structure like this ramp here or maybe a small bridge. This is really wonky, but just to illustrate. And we want to insert some kind of sections or be able to get sections along this deck in a GA drawing or similar. So we can now use frames that we have in Grasshopper. So we have generated some frames along this alignment. And then with the grid plane component, we can insert grid planes on each of those frames that we see in Grasshopper. And if we look at them just for illustration, like this is how the planes have been defined here in Tekla. So they go through the frame here, and then with this setting, they go perpendicular with or vertically down to the ground. And whenever it then intersects the ground plane here in this view, it will create a grid line. If I want them to be perpendicular, like we had them defined in Grasshopper, I can turn off this align vertically. And you can see that then it tilts them according to the frames we had in Grasshopper. And again, when they intersect the bottom here of the view, it creates a grid line. So now if I want to have a section here, for example, along the 12th grid line, I can create a view along that grid line. Set Y is enough in this case. And I need to click generate as well, I guess. Create. And now I can open that view, and this looks a bit silly because these are just one piece, so they are still visible. But if I create a GA drawing quickly from this view, then with the view thickness, I'm able to adjust so I get just a cross section on that perpendicular view. So this is something that has been asked from time to time.
Yeah, especially with in the curved structure, in the complicated bridge or stairs, this could be really great workflow.
Yeah, but now I've taken more than enough time. I think it's time for the star components of the show. So I'm giving it over to you, Simon.
Yeah, Simon. So I will share. Thanks, Sebastian. Of course, we are going to share this script with this amazing new features that we have, and yeah, Simon, the stage is yours. So now we're going to talk about welds and rebar sets, right?
Yeah, exactly. So, and I will start with the welds because those are pretty much straightforward, and I will keep this kind of introduction as Sebastian did or going through because those are new. So I will basically show how they works. It's not a really very fancy model or anything, rather just going through this is how they are meant to be used. So just feel free to ask questions meanwhile. So this is kind of new. This is the weld component. You will find it in the Tekla tab and in this steel category with this weld component, weld icon. The weld itself take like a main part, secondary part, a curve. I will get back to why we have a curve, common attributes, weld attributes above and below, and tail information. And with that, we have also implemented some new attributes components, and those are to be found in the attributes tab here. And they look like this. The first one is the common attribute for the weld. And then we have this kind of more specific, like weld above or weld below, which is repetitive with the prefix and the type and the size and so on. And then we also have the final part with the tail information, which we also made as a single attribute. And we believe that that would make much sense in how we divide them. And we can have some examples for that as well. And from here, I have created a very simple beam, this one, and I have also created two columns. And it's nothing fancy about those. It's just normal grasshopper work. And by default, when we insert the weld, if we place a main part and then we also place a secondary part, we will get the weld that is the same as connect welding parts together. And you can also add more main parts or more secondary parts and so on. So in this case, if I add the other column as well. To here, I will get the same weld on both places, and I can remove them off and on as well, even though I don't really see the benefit of going back and forth, but you can still remove one and you will keep the others and vice versa. So it's perfectly fine to just change them back and forth.
What about the output? And what about output if you connect to, is it in the lists or in the,
yes,
what is the output?
The input from those are lists, and you will get two separate welds. So when I select this one, it's still like two weld objects, but I control both from the same component. And by then, if we add this kind of common attribute, which is more or less all of those are kind of auto values, and that's also how we divided them. If I select this one and we have a look in Tekla structures in the property pane, we see that the first one are the common attributes, so it makes sense to have them separated as one. And then when we have the second one, which is those kind of attributes that you can find here, it makes sense to have them as one attribute component as well. So we can drag this one, for example, to weld above or weld below, and then we will get for each if we need to have welds on both sides in that sense. And then all of those works as expected, and it's just auto value. So we have true or false, or a workshop, true or false, and so on. So those just make sense. So there's no need to really go them through each one by one, but those are pretty basic. So that is kind of the basic how it works. So for my opinion, it's just how it should be. Then I can show another example, which is here, also a very fancy model part, where we have, let's see, I have a beam and I have the column. And as we described earlier on, is if we put in, let's see, so I'm just in the right location. Yeah. As we said earlier, if we put in a main part and a secondary part here, we get this type of weld, which is the same as connect parts. But if I don't want that and only want the weld from one side or another side, whenever I put in a line in the curve input, I will get a weld that is just, it still connects those two parts, of course, but it's the same as you have a line where it's only here I would like to have my weld.
When you extracted this line from the Grasshopper script, it's just the line.
Yeah, it's just a line. So this was just points.
Yeah.
But bear with me since I'm not a Grasshopper super experienced user, but it's still just all Grasshopper, basic Grasshopper. If I have another line, like goes from here to here, and I put that extra line in here, so I had two lines, I will then end up in having two welds, which makes sense. So if I select this one, it's no. It's, damn it, it's two objects. Hopefully you can see it, but otherwise you have to trust me. Then it's two welds. If I combine those two lines or a lot of points into a polyline instead, so I will only give one curve in that sense, or a polyline, I will have them connected, ending up that it's just one weld.
Yeah, so the Rhino input defined that. So if you're going to connect that in Rhino as a one polyline, so it will be as a one output from the weld component.
Yeah. And if you have multiple polylines, you will then have multiple objects, of course, but you can combine them depending on what you want to have. If for some reason you would like to have welds directly on one object only, I think there are some cases where you would like to weld something. Then this is the same beam. I just moved it here. If I put the same beam in main part and secondary part, then it will weld only that. But then you need to have a curve. Otherwise, it doesn't know how to behave because it's the same part. But if I, for example, then put in a line to that, it will create one weld wherever the line is. And the same goes from here. If I put in two lines, I will get two welds. If I connect those to a polyline and put in them, it will be one weld.
So you don't have to, you don't need two parts. So you can just create welds if you need for the object. So you can just create one object and define bad lines. Yeah.
Yeah, but you need to have one object to weld to in that sense, but you put it in main part and secondary part. But then nothing will be connected. So if I have another object on top of it, it will not be connected. So if you, for some reason, just want to weld something, I don't know why, but it's possible though. So I think that's pretty much it for the weld. It's pretty simple and straightforward.
We have some question from Andreas. Let me see, it's a little big question. So from Andreas, I have been testing the welding components lately and they show great potential. I'm helping a client that uses partial penetration welds quite a lot. And I was wondering if there are plans to enable us to set the additional size parameter through your components in the future. Size is not available in the attributes?
Yes, but I think his problem means something else. Because the size is there. But maybe we're referring to some other.
Maybe different type of the weld that you cannot define the size.
Yeah, because you have the size like from here, or is there on? Is there anything else? I don't I don't understand.
Yeah,
So
we can ask Anders if you can just write. Maybe it's a different type of the weld that you're looking for, but as I've been testing weld, so you can actually set it up from Grasshopper as well. Just
yeah,
so we will just wait for.
Yeah, this size is adjustable from here.
Mm-hmm. There is an additional size. It's another parameter.
Where do you find it? If we just look at the weld.
Maybe if you create that from. Maybe we can just wait for Anders, so he can just answer that one. Let me see.
Is it in user-defined attribute or something?
We can add Sebastian. Sebastian just said. Can you hear us, Sebastian?
Yeah. Yeah, I was just thinking if it might be an UDA that is then exposed in their environment that looks like a normal property. Because UDAs you can then set with the set UDA component, for example.
Anders just wrote that it's just for the partial penetration welds only.
So if I change the weld type, I guess, and then it should go. Okay. Okay. If it's not there, then I guess we need to look at it and see what we can do. That's probably something that I missed because I wasn't aware. So glad that you find it. But could you please like send a screenshot or something to me where you show how it looks and behaves, and like here it is, and it's when we do this and this, and then at least promise to have a look and see what I can do.
Yeah, that's we can. Anders, if we can just send more information. We have also one more question from Arthur's. All credits to you, for the developer, Simon. I've been with LiveLink since 2029. The development is huge. Question: how welds affect which part is a main part in case of multiple welds?
The one you put in as a main part should be the main part.
Yeah, because always in input you have to, as a weld, you have to define main and secondary part. So always when you're defining the first as a main part, so the rest will be secondary.
Yeah, that's the idea. And if you find any bugs, please let us know. But that's the idea.
Okay, cool. Let's go.
Should we go to the Rebar set then? Cool.
If there will be some new questions, so we will come back that, but you can just go to Rebar sets right now.
Yeah, cool. Should I just have? Is everyone familiar with Rebar sets compared to groups, or should I just spend 1 minute to just have the brief explanation of the differences are? What do you think?
Can you just repeat? I was like answering the.
Yeah, sorry. Would it be good that I just show very, very brief in 1 minute the difference between Rebar groups and Rebar sets?
Let's start. Yeah. Let's start with that. Maybe some people are not aware even about Rebar sets, so it will be good. Good start with that.
The idea is that you're basing things on faces or instead of points, kind of the basics. So now I'm going to do some manual work. So please bear with me. I have a concrete beam from here to here. And for example, if I want to reinforce that one with groups, there are multiple ways, but one way would be like you select the bar group and then you select the part you want to reinforce, click some outer lines or points.
To define
I might have to define the shape, and then I could potentially have pressed in the wrong place. Damn it. And then the direction or spanning like from here to here, and then it will reinforce it, which makes sense, and it's pretty handy. The idea with the Rebar set is that you kind of hover over, and then it will show kind of these are the faces or edges or surfaces, or call it whatever, that you want to reinforce, and then I could select the ones that I'm interested in reinforcing, like this, and click, and then it will automatically create. And both are adaptive in that sense that if I change this kind of form, it will adapt accordingly. Now we have more the idea of a guideline instead of this where it spans that we do with the rebar groups. So for example, if we have a concrete slab, I can remove this one. If I have a concrete slab, let's see if I can do something that would make sense. If I do something like, oh, if I do it. A weird shape though, but something like that. Then if I reinforce that one, we can do the same kind of crossing and select the ones, and then it will automatically area reinforce something. Now we also have guidelines to control the direction. So for example, if I have by guidelines, I can select the same, like which surface I want to reinforce or should be kind of the direction. And then I select, first going to make it a little bit smaller. Just bear with me. So I see what to input. Otherwise I might miss the middle button. So now I've selected the faces I want to reinforce. And then I press my primary guideline, which could be from here to here. And then I define the other guideline from here to here to here. And then I will get bars that kind of are going perpendicular or from the guideline to guideline. So you have more flexibility in what you want to create.
And you can change that, right? You can have more flexibility in rebar sets to change the overlapping and the hooks and just dividing with the different lengths. Mm-hmm.
Exactly. And I would say it takes some time to get used to it, because when you use groups, you just add like end hooks or you add whatever you want to directly. From here, it's more face-based. And then when you have the rebars that you want to have, then you add extras like end details, property modifiers, as you said, that's just a region of a part that should have some different spacings or whatever, or you could add splitters and so on. So it takes some time to get used to it, but it's pretty powerful. But what I noticed when I started to do this rebar set components, I think it was more easy. If you just have basic understanding of the Grasshopper link to Tekla, it makes more sense when I do it through Grasshopper. So yeah, let's see. I can go through it and then we see if it makes sense to you as well. So that's kind of the basics. Okay, and let's see if we can go here. I will just have the same very brief introduction, what we have created, and then we will use them in a similar way. First, we have these rebar set components, which take like part and the surface as shown, guidelines, attributes, which are normal rebar attributes. And then we need to have the surface attribute, guideline attributes, and if we want a closed shape, but that's another thing. And by that, we then introduce those kind of new attributes. This is not the new one. This is the old rebar attribute. But we have the surface attribute, which actually controls kind of the offset, and then which layer. I will show that later on. And if you want to or need to flip the bar side, and if it should react to holes. And then the guideline is what we are more used to control, like the number of bars or spacings or spacing times and those kind of things. So that is kind of how rebar set works. And then we have the extra things that we talked about earlier, where we have end detail, which could be like a hook or a crank or something. We have the modifier, which you can then set different type of rebar set within, or settings for the rebars within the rebar set without having to create many rebar sets. You can control one part of it or many parts of it. And then we have the splitter, which is also what it is, or pretty straightforward. And
after this update, when I downloaded first time the rebar set, I just how to say, I just seen how much work you have to put in the rebar sets, how many new components you inquire, because in the rebar groups there are maybe a little bit straightforward, but here the number of inputs and the modifiers and splitters, there are lots of work. So good stuff on that.
Yeah, but it's as you said, it's a bit complicated, the same as in the user interface. But for me, this makes more sense when you start just try to use them. So let's see. But yeah, there are plenty. So a little bit more complicated than the welds. But as I said, to every one of those, we have corresponding attributes. So nothing like the end detail, modifier, lapping or cranking. And then we have the normal hooks, which are the same as for rebar groups and splitter attributes. So yeah, we can start with, let's see if we have a Tekla beam, and we have a Tekla beam. This is also just by lines, it's a single one. From now, if we want to have this kind of surface or the faces of the beam, we can read them. You can, of course, create your own by just creating a surface or an area in Grasshopper yourself, but you could also read the faces of the created beam directly here. So if you don't want to pick out points. So in this case, we have this Tekla beam, which we have created in a normal way, and then we kind of B-rep it, and then we extract the faces with those kind of components. And in this case, we get all faces, which are kind of 6, I guess, 4 around and the front and the end. And then we get those kind of faces that we later can use for creating the rebars. And as said, we need a guideline, the same as I want the rebar set to go from here to here. So in this case, I have from here to here, I just put it here so it's easy to see and to follow. And then we have an object, which is the concrete. And then we have either an area or a surface that we can take as input. So now I will create this rebar set where I put in my part. I put in the guideline, which is a construction line in this case, just to show how it behaves. It doesn't need to be. And then I could put in either a face, which I have here, or an area. I will show how it differs later on, but the input is if I put in an area, when we create this one, I will have the thing, if you're somewhat familiar to rebar set, I will have the thing called leg face, which behaves in some way different, but not always. Or if I put in a surface instead, or surfaces, because I have many, I will have the thing called leg surface instead. And those
so it's just so this is the difference. So it's not extracting like the boundary from the surface, but it's actually creating like surface.
Yes, or like this. The input to the rebar set defines if you're gonna have a leg surface or a leg face. And in this particular case, we have read the faces. So what I get here is faces. And if I put in the faces, from here I've just combined in 2, like this side and the bottom. And I could equally drag in two surfaces instead.
Maybe you can also show it in Rhino to just show to people like how to what is the difference in Rhino, how they are seeing. If you can just zoom it into this boundary and to surface. Because maybe it's not straightforward.
I'm not sure. Do we see them here, to be honest?
Yeah, if you go to if you double click on the perspective view, so just make it bigger.
Yep, that would be.
On the text perspective, so if you click on the blue one, so it will be bigger. Yeah.
Okay. Are you sure that we actually see this one?
Yeah, I think so. If you go to in the Grasshopper, if you just click on the boundary with the middle mouse button and zoom.
This one or this one? This one.
Yeah, this one. Yeah.
Yeah.
If you and zoom on the right, you have this magnifying glass with the little bit down. Yeah, this one. Correct.
Cool. I wasn't aware, but now I am. So, and this is, I guess, the green one, which shows the left side, which is this one. And if I do the same with that one, I will get the bottom one. Okay. So I will just, in this case, we just go through the entire concrete beam and get all the sides.
Yeah, correct. Okay. So it's now much cleaner to see.
Cool. And thanks.
Let's continue. No worries.
And if the same goes that this is adaptive, so just if I just put in one surface, I will get straight bars. If I put in another one, I will get another one. And if I put in two, I will get two. So pretty straightforward. So this is just I've just combined them as one. And then I will show this one in a sec, or in the later. Then I can just put in like the normal rebar attributes. So I can control the size and the bending radius and the grade and everything. And then we have a surface attribute, which actually contains like if I want to have additional offset. And then we have this kind of thing called layer order, which is actually in what order we place the rebars. But in this case, we only have one rebar, so it doesn't matter what I put here. But if I put another rebar set here, and I put it in the other direction, like longitudinal bars, then I need to have the guideline in the opposite direction, which makes sense. So I will do that as well and try to speed up things a bit. Let's bear with me. And I will show you the guideline attributes as well. See if I have plenty. Yeah. If I put in the guideline attribute, I will have all the kind of things that we really need to adjust, like number of bars and kind of spacing type. If we go by a target spacing like this, or if we want to go like flexible at the end and start with exact spacing or exact numbers or whatever. So we have full control over the rebar set from here.
I think for someone who is using rebar sets daily, so this is completely makes sense. All these values.
Yes, and it's also from here. It's how many auto values, so it's pretty easy to get going, and you get, from my opinion, a pretty good like. I have full control over what I'm actually doing, rather than in the user interface, which is much more tricky. So it's pretty straightforward, even though it's many components. If I then put in another rebar set, which I then put the guideline in the other direction, as said, I will get longitudinal bars. So that's what I'm about to do. So I put in the same beam as an input for the main part. I will only have the bottom face as a surface, and then I will put in the guideline as said in opposite direction, and then I will get the longitudinal bars. And from here I also put in the same sort of rebar attributes, which controls like the size and grade and everything. I can put in the guideline attributes as well. So something like this looks almost as it should. Now, when I use this surface attribute, which has this layer order, if I for some reason want to swap orders, because they will put, every time I put in a rebar set, it will automatically come on top or inside the others. And those are adaptive. So as long as I have a higher or lower number, it will jump in between. So if I have a higher number on this outer rebar set, which is this one. So if I start to manipulate the layer order here and put it somewhere above, higher than 2 at least, then it will come on the other side. So it will jump accordingly. And the good thing about rebar set is that they know what diameter they have. So we don't have to calculate anything. As long as we use the layer order, it will adapt. So if you have a thicker diameter, it will know that and adapt on top. So you don't have to calculate anything. which
And
is
I think it's the biggest. I think it's the biggest advantage of the rebar sets versus rebar group, especially if you have several layers. Let's say if you have a third and fourth layer.
Yeah.
So doing that on the rebar group and just changing one rebar, so you have to change all the layers. But here, everything is connected. So this is like a huge advantage over just rebar groups.
Yeah, exactly. So it's very adaptive in that sense. And then you have always this additional offsets and everything as well, so you can change it if you want to. Okay, let's see. Yeah, I can go to, I guess, this one before. There's also, which you can't do in the user interface. Let's see if I can just find the right one. Yeah, here it goes. If I would like for some reason to not use one of the faces that the object itself has, sometimes, especially when it comes to bridges and everything, you have a lot of different layers where you actually want to, instead of offsetting a complete group like 1 meter or whatever, you could define your area wherever you want to and use that as a surface or an area, and then you can use that one. So if I would like to reinforce this one in the middle for some reason, I have my beam, and then I have created a polyline, which is just in the middle, like a rectangle in the middle of the beam. And if I use that one as a surface, and then just put in a guideline, I can have a reinforce a rebar set wherever I want to, which is pretty powerful. And then
actually, it's not possible to do it, right? From the just without Grasshopper.
No, it's not from what I'm aware of.
Yeah.
And you can then, with the surface attribute, of course, control it if you want to. Let's see, if I want to put it to one side or the other, I can just do like this, and it will jump. It will update in a while. And you have this kind of flip bar side, and the idea with that is actually if you for some reason have a lot of concrete objects next to each other, since the rebar set itself doesn't really have a father the way that rebar groups have, they can from time to time jump in the other object. It's not very common, but it could happen. And then we have this kind of flip bar side, so we just you could flip it to the other side, and the same goes from here. So you can always use this one, even if the purpose from the beginning was to correct things if they have been in the wrong place. So now when I try to offset it will work the other way around if you don't want to go with negative values. Okay, let's see. I might need to speed up things a bit, right? I can show you some.
We have some questions, but just to show. I see that you have some bridge.
I have two things. I have both the details, and then I would have just that you can go along. So I can try to speed up things a little bit. This is a slab, and I can show you kind of what I did manually. So if I just see, that's a right slab. From here, I can select, like I showed in the example, one guideline here and another guideline here, which is actually a polyline because it contains 3 lines. So if I reinforce this one with the same idea, I have a part, I have the top face, and then I will have the line. And now I take the line which is here. If I just put in this as a guideline, I will get a pretty, like say, it's just straight bars. If I would like to have it more shaped, the same as the concrete slab, and I put in a line that goes in this direction with 3 points instead, which is this polyline, and I add that one as well, and just add another one. This is a line, this is a polyline, it doesn't matter. If I just put in this one, I will get the same kind of thing that I showed manually. So it's
And
pretty
it's only
powerful.
and it's only limited for 2 guidelines, or can I have more?
No. Now in 25 we can have more. I think for depending on if you use a surface or a leg face, I think if I remember correctly, we can have. I think it says so as well. If we have, I think it's 2 if you use leg surfaces. So in this case, it doesn't matter because I only have 2. But for leg face and in Tekla 2025, you could have more guidelines. And then just very quickly show you how those other things work, like the splitter and the modifier. If I have this kind of same rebar set and I would like to go for the modifier, first is, let's see, this is the same rebar set. If I would like to modify an area of this where I would like to have some other spacings, other diameters and whatever, I have an input of the same rebar set in this modifier component. Then I must provide a curve saying like I want to change my rebar set from here to here. So I have a line, just a line in the middle, and I will put it in as a curve. And then in that area, I will have a different rebar properties. So when I add these rebar properties here, I also could add other guideline attributes and so on. See if I can just see it from above. You see that in this area where my line is, I have different settings for my rebars. And whatever I choose in this, like number of bar or spacing, it will just affect that.
So for everything modifier and splitters, you have to create your rebar set first, and then you have to modify. It's always like that one.
Yes, and that's the real differences from a group. But it's pretty powerful. And then we can do the same with the splitter, and I will not go into details here because we will run over time, I guess. So I will delete this one. Because it's easier to just show the splitter. And then I have a rebar splitter from here. I will take the same rebar set. And then again, I will need a curve defining where the splitter should be, which I have somewhere, I hope. There. And you get a default value where we actually split the rebar, and then depending on what you have for input, if you put in lapping or cranking, you will have different result. If I put in the lapping, which is actually the default, I can have a custom lapping, standard lapping, how the length of the lapping, if I want to lap on the right side or left side or middle side, depending on how it should behave. We could have the same as in the user interface, like all bars, every second bar, third bar, and so on. If I go for something else than all bars, I can also decide which one is the first affected bar. And then we can stagger, like to the right or to the left, meaning that depends on... damn it. Why didn't it...
I think you have to connect the splitter.
It's way better to connect the attributes before using them. Thanks. In this case, and then I can show every third bar, for example, and then we see that every third bar is affected. And then I can stagger it to the right, left, or middle. So whenever I stagger offset it, it will adapt. If I take every bar, it's easier to see. And then in this case, I have stagger right. I could have like stagger middle or stagger left or whatever.
Yeah, lots of flexibility, and you can program that with your standard like lapping zones and lengths.
So now it's a bit rushed in that sense, but it doesn't make sense for me to go through every single piece because it's pretty easy to just test. And compared to the user interface, it just connect those auto values and change it, and it will update pretty fast. So it's faster to see what the outcome is. And just the final thing for this is that usually you have this kind of splitter, but you have the possibility to have cranks as well. So if I put in a cranking attribute instead of this splitter attribute, let's change this one, I could have the crank with all those kind of settings as well. The same works like if I want to have all bars or third bars and so on, but you also have the custom cranking settings or standard crankings if you want to. And then you can set like the same as everything, the distance for this one or the offset, like how far it should bend and so on, and the total length of the crank. So it's pretty straightforward as well with full control.
Okay, and let's go to the last example. Is a bridge.
Yeah, it's exactly, and it's bridge to bridge, but whatever, something that looks like a bridge. And this is an item, and that is kind of the idea that I want to show, that we have an item and not a concrete object. So it's an item in Tekla structures, and from this we could still read all the faces, same as we did with the rectangular beam. And from here, we can then just choose the same kind of faces that we want to use or areas. So I will put in this rebar where we have, this is the deck, which is the main part. And then we will put in the surface, or surfaces, like 3 of them. I will have this kind of C-shaped bar. And then I will use the road line, which goes along with this deck as the guideline. And from here, we get it kind of reinforced. And then goes along with all the rebar settings and so on. Let's see if I can make it more clear. Something like that. And now it's time to actually show these end hook things, which is pretty clever. No, bear with me, I forgot. When we have put in surfaces, we get, this is a good example, because here you can see that we have one large surface that we use as reinforced. If we would use leg faces and have the same input, so we take this face, same as the combined one here, and then we read out the outer line, it will divide itself into smaller chunks to get kind of rectangles. So if I put in leg faces instead of the surface here, we will get the same bars. It looks the same, but as you can see, it's divided into smaller chunks. So all of those are their own leg faces. So you have even more control of individual parts, but it will probably take up more memory. So here you can see a real difference between surface and leg faces. If we would like to have end hooks, just as an example for this, I will add this end detail. I put in the rebar set as the input. And now one good thing is that when we add this end detail modifier, we need to have a curve or a line, like this side or this side of the bar should have the end hook. It's usually not hard to choose that one because it's the end. You usually put in end hooks at the end of the bar, so it's pretty straightforward. But in this case, it could be somewhat tricky to have the same curve as we have here, and it's hard to read that curve directly from Rhino if you're not a really Grasshopper super experienced user. So what we did was that we did find a way to take the first and the last leg of the bar, and then at the end of each bar, we will create a dummy line, which is not shown, and then offset it quite a bit. And then we put the end hooks at the end of each bar. So you will get them for free. If you're not satisfied, you can please add your other curve and it will override this one. But otherwise it will get according to the shape automatically. So you don't have to find that line, which I think is beneficial. And you will, by default, get end hooks in both sides. If you're not satisfied, you have this default side switch. So you can change yourself if you want to have both. Start side, which removes them from the end side, and vice versa, and both. And by that, you could also then have all the hook attributes. So if you put in the normal hook attribute, you can change them whatever you want to.
Yeah, the same is the same from the Rebar group, right? It's
exactly.
It's not the new one. It's the same.
It's the same. And then if you want to have cranks instead, for some reason, you just add the crank attribute instead of the hook attribute. And then you're able to, it usually goes red because it's hard to create those in a good way. But let's see if I can manipulate it somehow and get it back on track. It's usually, yeah, something like that. And then you have the same, cranking object as you did in the other examples. So yeah, a bit speed up in the end,
Yeah,
but you get the idea at least.
But yeah, the most important that like I saw also the update in the new 2025 that you have new inputs like a chamfer or inherited objects like that. So I see that you are still developing that. So it's good to see that you're adding more and more stuff, and good to see that it's working.
Cool.
Okay.
I guess that was pretty much it. Yeah, thanks.
Thanks. And for everyone, if you have any question, we'll just have a quick Q&A session. We still have some time. Thank you, Simon. I will just make a short presentation. So I will just share my screen. Just would like to remind you. Let me see. So yeah, if you have any question, just write on the chat. In the meantime, I'm going to just say that Grasshopper in Tekla training it's going to be released next week. And what is Grasshopper in Tekla training? Is an online training that opens the doors for the starting automation in Tekla structures. So all the boring stuff, and you can create your own tools. So we are presenting all the practical knowledge and in the Tekla real projects. And we are building supportive community. As I said, it was 200 people, and we are accepting also 200 new people in this one. And for those who are already in the first edition, they can extend access for the next year as well. And maybe which is most important, it's made by trainers, but by me and Greg, which are experienced in teaching. We have recorded lots of videos and supporting with the lots of case studies. So all the case studies are created based on the real project. So you can see we have 16 floor building with the concrete. We have also velodrome arena, bicycle arena with the steel and prefabricated objects. And of course, as I'm a bridge designer, so we have also amazing bridge examples where we are showing all the reinforcement, also making railings for the steels and pre-stressing cables. So this is agenda for Grasshopper in Tekla training. We have 10 modules. You can find it on grasshopperintekla.com/agenda. So there we can see we go through the simple elements, we go through params and edit components. In advanced elements, we go through welds, we go through components, and we go through shapes. Then we have reinforcement. In reinforcement, we have all about rebar group. We have also adding new components, which Simon just showed with the rebar set. And then we're going through extract, modify, which are modifiers component. User interface, we have lesson about Grasshopper component and human UI. And Greg is made a great module about the drawing automation. So Greg prepared more than 60 lessons with the practical examples. So it's the best way to learn from someone who actually create this drawing link. And Greg is really active on the Discord group. So actually you can have impact on which direction this Grasshopper Tekla drawing link will be developed. To sum up, we're going to start recruitment next week, actually on the next workshop next week on Tuesday. we are going to share the information, but the best way to get information as the first one, you have to save a spot at grasshopperintekla.com, so you are going to get more information. Let me see if I can see more. Let me see. There are two workshops left in this year about Tekla and Grasshopper. So next week we have 4 steps to automate Tekla with Grasshopper for everyone who would like to start with automation in Tekla with Grasshopper. I'm going to share some 4 basic scripts that you can start away. And on June, Greg, creator of Grasshopper Drawing Link, will be my guest, and he's going to show great scripts how to automate drawings in Tekla structures. He's going to show the low hanging fruit, how you can, without any like huge use time on script creation, how you can benefit from that link. So that's it from me. Let's go for the Q&A session. Simon and Sebastian, just welcome. We have some questions. Maybe we can start with the first one. Yeah, can I use these bars to be converted to be used in Revit? Sebastian, I suppose you already got this question many times, and I know the answer, but yeah, maybe you can.
Yeah, I mean, I'm obviously on the Tekla side, so you can export them as IFC and use the Revit link and so on, but I have no idea how they are getting accessed on the Revit side, to be fair.
Yeah, and actually it's not possible. They are created in different ways, but actually there are some workarounds how to create rebars in Revit through Grasshopper, but the workflow is much different. So it's the different ways. What about assemblies? Is there any component I can use to copy an assembly? Question from John.
Yeah, that's a good question. There's no existing component, first most. There are ways with scripting components to use the copy and move commands in Tekla structures. The thing to keep in mind when copying an assembly is that I don't think they work on the assembly itself. You need to grab all the child objects of the assembly and then copy them. So, but that's something I could share. I have some script that does this. So I'm not sure about the channel, but if you, for example, put this question on the McNeil forums, the Rhino forums, then that's a good place where you can share scripts like this, for example.
Perfect. Stefano, thanks. The new Rebar set component seems quite promising. Can't wait to test it in the next project. So this is the aim with this workshop, to promote it, and so people can use it, and maybe in some time there will be more Rebar set users than Rebar group. Again from Anders, another wish for the weld component, being able to draw a custom weld cross section would be really helpful. But being able to draw a custom weld cross section, it's not possible if you make a polyline today with just in Grasshopper, because I think just Anders is wishing for maybe it's different cross section than the two welded parts.
Maybe maybe it's not like it's the weld itself. If you cross section the weld and not the predefined ones like fillet and the others, like you want to have something else, but that's
okay.
I think it's a limitation in Tekla structures rather than in the component in that sense, if I understand correctly. So
yeah, I think so true.
So we can try to bring it up with the steel developers and see what they say about it, at least.
Yeah, it depends how often these custom welds are used. Do we have any more questions? Maybe you can tell Sebastian and Simon what is coming, what is in the pipeline. I know that both of you are really have lots of things to do, but what are on the top of the list of the priorities?
What will we talk about, or did we talk about last? I know This is not a promise, but I know that people in the US are struggling with the unit conversions. So for some inputs, I think we mentioned this in the last webinar as well. So for some inputs, you can work in imperial units, but for others like parametric profiles or offsets and cover thicknesses and stuff, you might need to convert to millimeters. And this can get a bit annoying and confusing. So that's something I would like to find a solution to.
So, for example, if you have some profiles defined in millimeters, so they can be also defined in inches.
Yeah, exactly.
Yeah, maybe this is the reason why Grasshopper is not that popular in US.
Yeah, but also I think it's getting more and more popular, at least the Tekla side. So that's why we get the pressure now to solve this somehow.
What about the bolts? What are the biggest nightmares of bolts? Is it something limitation of API that bolts are still not available?
I thought so when I first tried it many years ago, but then this reseller I maybe mentioned in the pre-show, they have found some solution to it, and it seems to work okay. We're just waiting for them to release something final.
Yeah. Sergey asked, any plans for creating components for analytical model? Because there is a different live link to Tekla structures designer, right? So there you can make an analytical model. But do you have any plans to do it also on live link, or is just out of scope?
We don't have it yet, but having Simon here to support means that we could be able to do stuff like this, because that's also a pretty self-contained package, which is easy to separate from the other development.
Yeah, it's also a very good idea.
So, do you get very often this question to make this analytical model components?
I've seen it maybe only once before. So that's also something to keep in mind when prioritizing. But if we suddenly see a lot of this on the forums or in other contact, then for sure we'll consider it. I think right now the most common way is to generate your analytical models through Grasshopper, and then only after that you go out to Tekla structures.
Yeah, this is what we've been showing in the latest last week. We have the webinar about Karamba, and then we have created all the analytical members itself in Grasshopper and then send it to Tekla. So it was working quite good. Okay, I do not see any more questions. Thank you, Simon. Thank you, Sebastian. And yeah, we had lots of comments that everyone is supporting your work. So Simon, great work on additional components. We can maybe write a letter, like all the people attend this here. Maybe you can sign up the letter that your percentage of developing the Grasshopper components should be increased, not just 25%, maybe more. So maybe Trimble will get it and see that actually you're helping for the community and people are using more and more. So my fingers are crossed that you can stay longer. So actually, your additional work was planned for some months, but it's already 1 year. Am I right?
Yeah, that's correct.
Yeah. So I hope that Sebastian will keep you longer. Thank you, Sebastian.
Yeah, it's been a great addition to have Simon, and thanks, Chris, for having us. It was a pleasure.
Yeah, thanks for having us.
And yeah, let's take eye on all the developments that Sebastian is giving on the warehouse. So you can see lots of good comments. Thank you guys. And yeah, let's see what will maybe in a half a year, maybe next webinar, what's new in the Tekla Live Link 1.20.
Awesome. Thanks everyone.
Awesome. Thank you very much. Bye bye.
Take care.
Bye.